factor everything. We want to factor everything if we're multiplying. If there are multiple terms in the numerator and denominator, terms, things being added and subtracted, and they don't already have parentheses around them, we might want to draw some parentheses around them. Might help us out a little bit. Cause like x plus 2, we can't cancel just that x. But if we put parentheses around the entire x plus 2, we might realize that we can cancel the x plus 2. How do we multiply fractions? So if I gave you a problem like, maybe like 2/3 times 3/5, how might we multiply those two fractions together? Straight across the top numbers and the bottom numbers. So we're going to multiply the numerators and we're going to multiply the denominators. We do not cross multiply and we do not have to find a common denominator. You could find a common denominator, but it's really unnecessary. And then after we multiply, we might want to reduce that fraction. But actually, we can actually reduce the fraction before we multiply. And that's probably what I would recommend. It doesn't matter when you reduce it. But like right here, is there something that we could cancel off right here before we actually multiply them together? No. Yeah, we can cross out the 3's. We can actually cancel those 3's out. And then that's kind of like a 1 left over. So we really just end up with 2/5. So we're going to do the same thing today with rational expressions. They're going to have variables in the numerators and denominator. All right, when we talk about dividing, what do we need to do when we divide rational expressions? We still need to factor everything. That's why we spent all day Monday talking about factoring. If there is something that does not have parentheses around it, like an x minus 1, it might be okay to put the x minus 1 there. It might help you put the x minus 1 there. How do we divide fractions? So if we had something like 1/2 times, not times, my bad, 1/2 divided by 3/2. How might we divide those fractions without a calculator?
You would flip the 3/2 and then multiply.
Yeah, we would keep the first expression. So we're going to keep the 1/2. We're not going to change it. We're going to change the division to multiply. And then we're going to take the inverse or the reciprocal of the second expression. The multiplicative inverse, that is, of the second expression. So that would look something like this: 1/2 times 2/3. And then once we change it to multiplication, guess what we can do? We can follow the rules for multiplying. You can follow the rules for multiplying. The 2's would cancel out, and we get 1/3. The 2's canceled out, and we get 1/3. That's your notes. I got some examples on a different sheet of paper card.
It's been going back quickly.
Yeah. Get it done.
I like it.
4 examples, takes about maybe 10 minutes. You know, we know for today. Number 1, x squared, x to the third plus 9x squared. How might we factor everything? So we're just going to start factoring everything. So let's start with the x to the third plus 9x squared. How might we factor that piece?
2x.
We can factor out an x squared. We can divide by x squared. The x squared goes outside the parentheses. And what we get when we divide by that x squared goes inside the parentheses. So we had 3 factors of x inside the parentheses. We're taking 2 of those factors away. So we're left with 1 factor of x. 9x squared, well, we took the x squared away. 2x, can we factor 2x?
No.
Nope, cannot. All right, the second fraction, what can we multiply to get 45? That adds to give us negative 14. 9 and 5, it's gonna be, both, need to be negative. And the 81, what can we multiply to get 81 that adds to give us like a 0x? It has to be the same number. So the easiest way to find that number might be like taking the square roots of 81, which is 9. So we get positive 9 and negative 9. For instance, if we had something like x squared minus 256, it might take you a while to figure out what the number is. But if you take the square root of 256, it's going to be a lot quicker to figure out how to factor that. Now, what can we cancel out? We can cancel out any like factors that are in the numerator and denominator, even if they're on opposite sides of the multiplication. So the x plus 9 is in the numerator and the x plus 9 is in the denominator. So we can cancel those out. I wrote -1, it should have been -9.
Can we do the negative 9?
And then the x minus 9s, because we have 1 in the numerator and 1 in the denominator, we can cancel those out also. If they're both in the numerator, they don't cancel out. One has to be in the numerator and another has to be in the denominator in order for them to cross out. What about the x squared and the 2x? Can we cancel an x out? Yes, we can cancel an x out because we're multiplying. If we were adding, we wouldn't be able to cancel the x's out, but since it's because it's x squared times 2x, so the x squared is going to become x, and the x is going to cancel out. So we can cancel an x out. Now that we've canceled everything out that can cancel out, we're going to multiply what's left in the numerators. So x and x minus 5. So we're just going to multiply those together. We're actually not going to distribute the x. We're just going to write it as though they were being multiplied. It would be better to leave it like that, probably, than try to distribute it. It's not wrong if you distribute it. It just depends on what you want it to look like. I probably want it to look like this. If I were going to do anything else with this problem, this form is going to be a little bit easier than if you distribute the x. All right, cool. Number 2, we are dividing. So we're gonna do this keep, change, flip idea. Maybe you learned it that way back when you first started learning how to divide fractions. Maybe you learned it as keep, change, flip. So the x plus 4 and the x are gonna stay the same. We're gonna change the division to multiply. And then what are we gonna do to this second fraction, this second expression? Well, we're going to swap them. I'm going to swap and factor them at the same time, just to save some writing. So what can we multiply to get 20? That adds to give us 9. 5 and 4, that goes in the denominator, because we're moving that x squared plus 9x plus 20 to the denominator. So the x plus 5 and the x plus 4 are in the denominator, not the numerator. And then the denominator, what was the denominator? We had 10, what can we multiply to get 10? That adds to give us 7, 5 and 2. We talked about those invisible parentheses earlier. Like this x, here's what you might want to try to do, and it's not good. You see an x and an x, you might want to try to cancel those out. That's a no-go. Why is that a no-go? Because the x on top is a term, and you can't cancel terms. But what might help, what if I put parentheses around the x plus 4 and the x? Now if I cancel the x, I have to cancel the x plus 4. I can't just cancel x. I have to cancel everything inside the parentheses, which we can do with this x plus 4 over here. But I couldn't cancel those x's on the left there. And the x plus 5 and the x plus 5, we can cancel those as well. What's left on top? There's an x plus 2 left on top. That's the only thing left on here. 3. We're dividing again. 3x squared and 3x. We cannot factor either of those. You can maybe write it like 3x times x if you wanted to, but that's really not going to serve us well. We are dividing. It's really hard to divide fractions, but dividing fractions is equivalent to multiplying by the reciprocal, and it is much easier to multiply. So I'm going to go ahead and switch that to multiply. X squared minus 9, what can we multiply to get 9? That adds to give us 0x. We can do the square root thing again. That's going to be positive 3 and negative 3. But I lied to you. It should be in the denominator. Yeah, we should definitely switch it, because we are, dividing. The x squared minus 10x plus 21, what can we multiply to get 21? That adds to give us negative 10, negative 7, and negative 3. That goes on top now, because we are multiplying, so we do have to flip that second fraction. What can we cancel out? We can definitely cancel out the x minus 3's. Can we cancel anything else out?
3x.
We can cancel the 3 and the x out. And why can we cancel the 3 and the x out? Because they're being multiplied. What if it looked like this? What if we had 3 plus x squared on top and 3 plus x on bottom?
No.
You can't cancel any of those because they're being added. But since these are being multiplied, I can cancel the 3's and I can cancel one of the x's. So there's an x left over and an x minus 7 left over in top. So we're just gonna write x times x minus 7 on top. And there's an x plus 3 left over in the denominator. You can put parentheses around the x plus 3 if you want to. It's not necessary since you're not multiplying it by anything anymore. You don't need parentheses, technically. All right, we divided. All right, last one. Number 4. It's multiplying. The factoring is just a tad bit more complicated. We may have to factor the same expression more than once. So let's just try to factor all of these. 10x squared and negative 40. What might we try to do first? Yeah, divide by 10, good. That goes outside the parentheses. 10 divided by 10 is 1x squared. Negative 40 divided by 10 is negative 4. Can we factor x squared minus 4 again? Yes, I'll do that in a second. Let's just factor everything else at least once. And I'll come back and do this x squared minus 4 again in a second. What about 5x squared, 25x, and 70? We can divide all of those by 5. We do want to look for the GCF first. And if we can factor out a GCF, we absolutely want to do that first. Because otherwise we would be trying to do the box method with the denominator here. And then we're going to multiply 5 and 70, which is a really, really big number. But if I factor the 5 out, I don't even need to use the box method anymore, because then there's a 1 in front of the x squared. We are multiplying this time, so we're not flipping anything. X minus 2 cannot be factored, so I'm just going to write it open. Maybe put parentheses around it. That way I don't cancel the x or the 2 by mistake. I can cancel all of the x minus 2, but I can't cancel just the x or just the 2. X to the third and 7x squared, we can divide all of those by what looks like x squared on the outside. X to the third divided by x squared is x, and 7x squared divided by x squared is 7. We got to factor one more time the x squared minus 4 and the x squared minus 5x minus 14. We can factor those one more time. We can do the square root thing here again. It's a difference of perfect squares. X plus 2, x minus 2. This is technically bad notation, but that's okay. And then in the denominator, what can we multiply to get negative 14? That adds to give us negative 5. Negative 7, positive 2. We're multiplying this by x squared times x minus 7. All over x minus 2, put that x minus 2 in parentheses, otherwise you might try to cancel this x with that x. Can't do that, but we can cancel all of the x minus 2, so that parentheses might help us not make that mistake. Now what can we cancel? We can definitely cancel the x minus 2 and the x plus 2 and the x minus 7. Lots of things canceled out this time. 10 over 5, can we simplify the 10 over 5?
The 2.
Yes, because it is being multiplied. If it was being added, if it was like x plus 10 on top and x plus 5 on bottom, no, that is not can't simplify that at all. But because it's 10 times, we can simplify this. 5 goes into 10 two times, and 5 goes into 1, or 5 goes into 5 one time. So we do get 2, 10 divided by 5 is just 2. So we get 2x squared on top, there's the x squared left over here. And there's technically just a 1 left over on the bottom, which we really don't have to write, the 1 on the bottom.